Hey guys, so we're looking at stationary points. In this series of videos we've been looking at graphical calculations in terms of derivatives. So the last videos we looked at was increasing and decreasing the functions, where it was increasing, where it was decreasing. We're now looking at stationary points. So a stationary point, as it states up here, is a section of the graph where the gradient is zero. So we know when we have a zero gradient, if we go back to what we know in terms of gradients, we know that we have three types of gradients. We have our positive gradient, we have our negative gradient, and then we have our zero gradient. And this is the gradients that we're trying to look for when we're finding stationary points. So where on the graph can we have a tangent line that represents a zero gradient? So, if we're looking for a gradient, then what we need to do is we need to be able to differentiate a function to get that gradient. But what does that look like in terms of stationary points? Generally, there are three types of stationary points that we deal with. And these three types are type 1, where if we look at this first type here, we can call this here a maximum, or a minimum, a minimum stationary point. And I'll call it SP just for shorthand. And the reason why, because we can see that it's stationary. If we did a tangent line at this bottom part here, that's where we have a gradient of 0, at point 0. So our critical point here at point 0, it's decreasing as it approaches the stationary point, then it increases. The second one is our maximum stationary point. And again, it looks exactly the same as you would for a minimum, except for it's inverted. So here, again, we've got the stationary point where we have the tangent line equal to 0. That becomes our critical point. Alright, so we're now looking, well, what's happening before it approaches it? It's got a positive gradient, then it's a negative. So you can see with your sign diagram that it should reflect what the graph kind of looks like. And then we've got our third type, and our third type are what we call inflection stationary points. So, where the graphs are either continually decreasing or continually increasing. However, there is a certain point in the graph where we have a stationary point. And if we look at both of these here, I'll do these sign diagrams just in red so you can see the difference. We can see here that this here is decreasing. So if I was drawing gradient lines here, I'd have a decreasing gradient line, and it continues decreasing. So we would say that this here is an inflection, or a stationary inflection point. So this here is our maximum stationary point. This here is a stationary inflection point. So a stationary inflection point. Okay, and the reason why we call it inflection is because it's changing shape. And in this one down here, we have a positive sign diagram. So in this case, here, it's positive and then positive again. But we have our stationary point in the middle. So this here is the graphical way that we actually can see how stationary points look. Majority of the time we're going to be using equations, and in order to be getting an equation, what we do is we have to find the derivative of your function and equate that to 0. Okay? What we're going to do is we're going to look at a couple of examples in the next video. This is just an introduction to the stationary points, so that way you're all warmed up, ready for the big leagues.